Okay, it is a presentation about the Kōan tree, demonstrating morphological computation in locomotion. The project is with Tomomi Mahaira, Naritoshi Shuji, and me, Nicolas Figueroa. Tomomi and Naritoshi couldn't stay here, but they participate in the work. We divide the work into parts and show the work of all in this presentation, in this slide. Okay. Demonstrate morphological computation in locomotion, considering forward movement using now robot. Why we consider using now robot? Because it has a high flexibility and has various sensors. It's useful to control with high robustness and more similar to human. It's the reason for we choose the now robot, the around robotics. The characteristic of the now robot is the structure, because it has a lot of degrees of freedom, 25 degrees of freedom. It has many sensors, like a camera, a microphone, a pressure sensor, inertia unit, a tactile sensor. There's a lot of sensors that we can manage for try to use for some projects, maybe for educational projects, for research projects. You can see the form of the now robots of the around robotics. Okay, I am talking about the structure of ramp and stairs. It is one idea of the project. We thought do this project maybe like example for a morphological structure. The idea is stairs and put a robot in robots and try to do the robot walk on the ramp. Sorry. Okay. The robot climb the ramp by crawl to point from point A to point B, and then go downstairs from point B to point C. The characteristics of the stairs is the length, 40 centimeters. The weight is 25 centimeters. And we're thinking we can use this robot, the liberal robotics, for try to move, because we get some difficult parts when try to explore the robots. Okay, resuming his task to climb the ramp by crawl. Task is to go downstairs. This is the ramp downstairs, and the length of the ramp is 48 centimeters, as mentioned before. Then I show you maybe a little video about the model adopted for the crawling now robot, forward moving by crawling. Okay, we show a video. It is unfortunately the results must be shown as a bad example, because the robot has only one way movement of joints every time. Moreover, has no visual, no feeling. This is a problem. It was going well in control. The one first time was problem construction, but every clothing are slightly different in the most case. General trajectory fix will be quite easy to forward moving by crawling. Okay, you can show maybe that try we want to crawl. That is the intention in the webs. You can see in the video. I can show you the next slide. Okay. As a method for solving this problem, we know the sensory feedback, maybe the camera, the accelerometers, pressures, etc. By calculating perceive an error occurring in the real world. The robot represents such a CMO is modified joints trajectory in real time. However, the very fast computing power is required to implement in this approach. Okay, proposal for one idea. We have an idea inspired by animal control. In this case, a minimal dog, like a puppy robot. This was not in time to practical in terms of programming, the idea is assign a periodic function that contains the trigonometric function to all degrees of freedom, like a puppet robot. The periodic function of this given at a random, and all joints have a common frequency. The frequency that is one period of the prop. In addition, the parameters of phase and amplitude and variables are random. Yes, we can use maybe this idea for try to crop the robot, or maybe the work, the people robot, the now robot. But before to do this, maybe is some ideas for the mini dog, maybe with this periodic function, with maybe evolutionary algorithm, maybe algorithm, genetic algorithm. Okay. We want to use maybe evolutionary optimization here, through genetic algorithm, handles parameters, amplitude and phase of each trigonometric function and frequency and crawling as gen, and selects an individual more fast, more efficient to move forward. Then now can be acquired length basis. This is the best combination of parameters in the morphological form of humanoids as a result. Maybe I think. By the way, there are no sensors in this idea, but of course we want to use a sensor such as what animals use. The sensor may be the visual, touch, incline, and so on. On sensor are very useful for feedback during optimization and high level control. It is some research about Naritoshi that tried to share with us relation to the project. It is the robot implement with central pattern generation, the CPG. This study is combined for a nerve simulation. The people robot implements central pattern generation work by optimization and CPS parameter using genetic algorithm. By injuring the part of nerve, the robot becomes injury model. And then we consider compensatory strategy of impaired walking by applying GAA, genetic algorithm, to impaired model. As you can see in the video, a healthy model, when the robot tries to walk, but maybe the impaired model, you can see that it's not very good. It's maybe get some difficult part, but it's improved when you impair the model with a compensatory strategy. Now I show about the choreography and robots. I mentioned before about the now robots that try to do something, and this we explore the crawl, maybe the walk, down style, etc. And one idea is about the choreography unit but huevos, about the SDKs, about the now QI. Now, while you can use the choreography, this is a program of the now robots, and you can connect with robots, and you can maybe program maybe in Python and C++, etc. in choreography, and the movement you can see the huevos, or in the other hand maybe the huevos, you program in huevos, and you can see maybe the movement in the choreography. How I mentioned, this part use and now QI that you can use maybe in the Windows, Mac, and Linux, but a different language. That Python SDK is C++ SDK, Net, Java, MATLAB, etc. And your code with Open Now. Now quite try communication. Who work this part? Connects an executable to another robot with IP address and port. For example, in Webbots, you have to program and use the SDKs for now quite, and this use the proxy and create an IP address, and with this IP address, you you have a robot, a virtual robot that connect for choreography. when you connect with the IP address and port, the same movement in the robot, in the choreography, is the same movement in the webbots. For example, if you maybe hit the robot in webbots, this hit appear in the choreography, or in the choreography in the webbots. It is make the choice between factory cloud, APC, and remotely cloud. Is that connect that use now quite. Well, it is maybe it's a little structure about the who connect now quite with the models and the methods. The models is a class with a library that compiles as an executable files, or as a library. Executable files is maybe it's a remote control, or maybe it's a library if you use a local control. And the broker is a provider directory service and network access. And the methods is a function that you use, maybe get data, raise events, walk, maybe you go to forward, go to back, etc. So it's the movement that you program. And it is the video that try to program and connect with the choreography with now quite SDK. I hope that you can see the video. Okay. In this part, maybe you can see this but for box oil on the right side, and the program from webbots. In this part, what is the difficult if you use maybe only webbots for now robots? The difficulty is that you don't have all the movements of the now robots. Maybe you can move only forward, only up the hands, maybe go to back, but you have maybe five movements. This movement is a dot motion. But what happens if you want to, maybe your robot, you want to move, maybe open your hands and move one leg, etc. You can do it in webbots. But for this reason, is the use a choreography. And this part is the way try to program and try to go up the road. It is a part where you use a choreography. We use a choreography. You can use a stand up, maybe obstacles avoid, where you can program with Python that I mentioned before, and put in this block and connect with webbots. In this part, when the robot try to stand up, but it's the difficult of the morphological of the robot. It's not easy. Well, I can show you the other video. Okay, this other video is focused in the program, maybe in webbots, but it's without connect with choreography. You can see that you can move maybe the dimension, the hand wave, forward, backward, side step left, etc. You can program it in webbots. And maybe you can use some sensor, the bumpers, the camera, etc. In programming webbots is more easy because you have the movement and you only say, I want to go to forward, maybe maybe 3 meters, etc. Use the accelerometer, go right, go left, etc. But if you can maybe improve the program, I guess it's necessary to use the SDK now quite for more tasks in the robot, on our robot. We try to explore with this, and we try with this presentation show different case. We try to explore webbots the difficult on morphological, and maybe propose genetic algorithms for the movement, whether for crawling or for down the stairs in the robot, for improve the different tasks. Yeah, this is the the presentation, the result of the presentation. Okay.
Thank you very much. Excellent. Let's see if we have any questions from the TAs. Any questions? Tatiana, go ahead. Go ahead, Tatiana.
Can you hear me?
Yes, yes.
I have a question. You said in the beginning that for using sensor data, you need a powerful computer. How do you think? What must be the computer like? So, is now internal computer suitable for using sensors in locomotion? How do you think? Which computer is needed?
Okay, you mentioned about the computer task. I can hear is very slow. Hello.
Yes. Go ahead,
Yes,
Nicholas.
is your reference about the process in the why consider the computation computational I guess you're referring to the why we consider to improve the task, maybe for some algorithm, etc., for reduce the computational task. Yes, the now robot maybe that have some processor, etc. But I guess is you improve maybe with some algorithms, you can do maybe some tasks very with powerful. You can program more fast, and maybe you can get problems with the lab. For example, the simulation I use with the virtual machine and use the webbots and use the choreography. But some movement you can see in the slide, the robot maybe can stand up. This problem is because when choreography send some information, you get a time delay. In this time delay, maybe the robot is maybe move your hand, or maybe move the hand, or maybe move the left. But receive the information very late, entonces then the robot drop, or maybe the robot go to the floor because the late in this case in the simulation. Was a problem, the delay.
Okay, thank you. Any other questions? Okay, I just had one quick one. We're running late on timer. I just want to ask you you were talking about the task about crawling with the now up the stairs, for example. So does now have any passive compliance in the joints? And if not, do you think that could help in such a crawling task? Nicholas?
Yes. I don't have errors, so I can only hear with the speaker of the laptop. You mentioned about
Okay.
the Jones.
Yeah, I was just if you can comment on the now and whether it has any passive compliance, or if all the joints are activated by motor. So if you wanted, for example, have the robot crawl, would it be helpful to have some passive compliance in the robot, like the puppy robot?
Okay. Yes. We have one idea is about the puppy use the puppy robots because maybe with a function trigonometric function maybe we can use in the when the robot try to crawling. Maybe it's only the first and the part in the program is only crawls. The robot is trying to crawling, but it's only move with maybe with some commands, etc. But we consider that if we can improve with some genetic algorithm, etc., with use the geometry, maybe the function geometry. You can the robot improve the movement maybe with some periods of some frequency of the problem. Maybe move some hands, maybe the other hands, etc. If you improve the period of the movement, you can you can make a road try to do a good task. This is the question.
Yeah, I think so. It's a bit hard to hear with the audio. It's a bit bad quality right now, but I think so. So, do we have any more questions?
I have a short. I have a question. How you show morphological computation in your example? Where you show it?
The morphological computation is give an example of different programs for trying to do in a robot, in the maybe in the dog robot, maybe in the now robot. That it is the principal example that who can programming, who try to walk, maybe try to crawling the robot, and maybe use webs, maybe try to connect with other programs that is in case use choreography.
Okay. Then I think we finished there. Thank you very much, Nicolas and Group 3. Good work. And then we move on to the last one, which will be the presentation from Poland.